In this video, we will learn how to prepare the data for training object detection model using Sagemaker's Jumpstart TensorFlow. Okay, so um, the Jumpstart TensorFlow model expect the data format slightly differently as compared to the image classification and object detection models we saw in the previous videos. Okay, for example, the SageMaker's inbuilt SSD algorithm, it expects these 4 folders, right? So the folder names can be anything, but it expects all the training data in one folder, the training images, and then the training annotations. It expects one JSON file per image in a separate folder, and similarly for validation images and annotations, right? So these 4 folders. Now the TensorFlow Jumpstart model, it expects the data differently. So it's like this. So all the training images and data in one folder like this. Now within this root folder, all the images should be this images folder, and then all the images should be in a single file called this annotations file. Okay, not one one JSON per image like inbuilt uh, uh, algorithm. Okay, and similarly all the validation images in this images folder, and also all the annotations in this single annotations file. Okay, now let's look at this format first. Let's see this in Visual Studio. Okay, so the annotations file, it contain all the images data, and it contain mainly 2 sections. So the first section is this images. Okay, it's a list again, and each element is a dictionary containing information related to each image. Okay, so for example, this one, the first image, here we have the image name, the height and width, and ID. Okay, and this information, it's for the second image, the name, height and width, and ID. Okay, so the first half section of this file contains this image information. Okay, so that's it. Okay, so for all the images, their names, their sizes, and for each image there is an ID. And then the second section of this file contains the annotations. Okay, now the way the first section and second section are going to be mapped is using this ID. Okay, so that's why we need this image ID. So even though it's called ID here, it's called image ID here. Okay, so corresponding to each image here, we can have multiple rows, obviously, if the image has multiple objects. Okay, so this one is used for mapping image ID. And then finally, we have the bounding box. It's a simple list with these 4 elements. So unlike SSD model, we don't have a dictionary containing these 4 elements as left, top, width, and height. Okay, so it's simply a list with all the 4 values. And then finally, it contains the category ID. Okay. All right. So we are going to prepare this data for the train and validation using the output from make sense, which is this. Okay, we have discussed the format of this file in the previous video, but again very quickly. So we have the image name in the last 3 columns. This is the image name, and then the image width and height. Okay, so the image width and height, and then in the first 5 columns we have the label name and the bounding box coordinates. Okay, the 4 coordinates. All right, let's jump into the code. We have seen all these libraries before. So here we have first created two folders. One is called train image and annotation. So the train images and annotation, and within that folder, we are going to create another folder called images. Okay. So we have created another folder called images. We did the same for validation data. Okay. And then we are reading the output from make sense. We are already familiar with this format. And then splitting the data to train and test. I mean, here we are just finding out how many images. The actual splitting happens a bit later. We have created the labels file between the classes to the class IDs. And then we use this labels mapping to create the class ID from this label name. Okay. Now, in the last few videos, I must be using the word label, class, maybe even object interchangeably. That's because, again, these different algorithms, they use different nomenclature. Okay, right? So that's why I'm using these words interchangeably. Now here, one important thing we are doing here is, for each image, it is expecting this ID, right? This ID. Okay, so I mean, let me go to the one. So for each image, it's expecting an ID. Now what we did here is, so using this rank function in the dense method, in the dense mode, for each image we are giving a unique ID. Okay. Using this image name column, because this is object detection ground truth. As you know, each image can contain multiple objects, meaning multiple rows. For example, this image contain 2 rows or 2 objects, whereas this image contain 3 objects. All 3 objects are 3 rows, right? So for this image, we want to give one ID. For this image, we want to give a different ID, right? So here what we are doing is, by taking this image name, we are creating a rank in dense method. Dense, what it does is, for each group, for example, this is one group, this is 2 group, right? It will assign the same ID. Okay. Now this 6724, that's because when it did the ranking, it organized the data or the unique images in ascending order. So this image, it happened to have the 67th in that row. Okay. But again, the exact ID value doesn't matter as long as we have each image mapped to a unique image ID. Okay. All right. So then here we have got all the images, right? All the 100 images we have in this data set. And then we are sampling n train number of images. Okay. So basically from this list of 100 images, we have found out 70 images which should go to training. Okay. And then there should be a list. You can take it as a list, right? And then we want to subtract the train images from the total images so that we can get the validation images. Now we cannot subtract the list, but Pandas has this, Python has sets. We can subtract sets. Okay. So here we are subtracting the train images from the total images so that we get the validation images. And if we look at the count here, so out of 100 images, 70 are going for train and 30 are going for test. And these split ratio we found here, right? 70%, because we have 100, 70% is 70. All right. And then if we look at the number of objects the train images and validation images going to have, so here what we did is, using this ground truth data frame, we are filtering the images which are in these train images. Okay, so this will give us a new data frame which contain only the images related to train. Similarly, this data frame contain images related to validation. Now, if you look at the length, that would give us the number of objects, right? So the 70 train images, they have 117 objects. The 30 validation images contain 44 objects. Okay. All right. We get to the final part and the most important one. So we are going to create these two sections. One is this images section and the second one is annotation section. So let's start with this images section, right? So it is in this format. It's a list and each element is a dictionary, and each dictionary contain the 4 values: the file name, the image height and width, and the ID. Okay. So here we are defining a function. It takes a data frame as input. Now using this data frame, so it first get all the image names, and here we are defining an empty JSON images list. Now we are going over the images one by one, and then for each image, so here we are filtering the data frame to this selected image. Okay, and as we know, each image can contain multiple objects, so this can be more than one row. But because these properties are image level properties, they are not going to be changed based on the object. We are just taking the first row from here. Okay, the first row from here, and then converting it to a dictionary. Okay, so this one contain the image level properties. Okay, for example, it contains the image name, the width, height, the image ID, and of course all other information, all this information for the first object. Because we are not going to use this first object information, we are only interested in this global image level information. This method works, right? Choosing only the first row. All right. So using this dictionary, we are extracting these 4 pieces of information we wanted. First, image name, which should with the key file name. We already knew it from this image. And then we want the height, width, and ID. So height, width, and ID, they are in this dictionary in the form of image height, image width, and image ID, right? So basically coming from these 3 data frames columns: image width, height, and ID. All right. So we have the image level dictionary, and then that's for the first image, right? Then we are looping over all the images and we are appending the data to the JSON images and returning it. Okay. So when we run this date function with the train data or train data frame, we will get this first section, right, for all the training images. So we'll get this dictionary part, this part. Okay. Now we are going to create another function which will return this information for a given data frame as an input. All right. So here we are creating another function for the annotations part. Now the annotations, it should be in this format. So first we should have the image ID, then the bounding box, list with 4 elements, and finally the category ID. All right. So this time we are iterating over the objects, right? Or iterating over the rows, right? Whereas here, because this is image level information, we found out all the unique images and we iterate over the images. Whereas here, because this is object level information, we need to go over all the rows of the data frame one by one. So we are iterating over the data frame. Now we are creating this JSON dictionary, the local variable for this particular object. Okay. So the image ID, right? So the image ID, so it's coming from, so when we iterate over rows, it returns two values. One is called this index, whether we use it or not, that's going to be an index or the row ID. And then this one is the actual row, right? This row, we are calling it object. So from the object, we get the image ID and then the bounding box. So it's a list with 4 elements, right? It's with these 4 elements. So the object left, top, width, and height. Okay, so those 4 coordinates. And finally, the category ID. So the category ID, again, we are coming from object class ID. Okay, again, so it must be coming from the class ID. Yeah, the class ID. Okay. So we gather the object level information for one object, and then we are looping over all the object or all the rows of the data frame and appending it to this JSON annotations file, right? And then finally we are returning this file. Okay, so these two functions we are going to call with train data frame and also validation data frame. That's what we did here, right? So we split the data into train data frame and the validation data frame. Okay, so in this section, we have called the images dictionary function with the train data frame. We collected it into this JSON images, and then we call the annotations function again with the train data. So we got this JSON annotations. Now, as our annotations file, it has these two sections, images as well as annotations. We are simply going to combine these two results. So here we are creating a new JSON with train. So it contains this images, which is coming from this JSON images, and then annotations, which is coming from this JSON annotations. Okay. And we just write the file now, right? Finally. So we are opening this file. We are writing it to this location, train images annotations. Okay. So we are writing it to train images annotations. So first we are going to write this file. Now we have created this file, but we haven't copied the images yet, right? So we are going to create this annotations JSON file. So annotations JSON file, we have, so this one. So we have done for the training data, and we are doing exactly the same thing, but this time for these two functions, we are supplying the validation data frame. Okay. And then we have created the annotations file in the validation folder. So the train one, now the validation one. Okay. And finally, we simply need to copy the files or the images, right? So using the shuttle function, we are going over all the images from the train data frame and copying them from the source file, which is this all images GT. Each image, we are copying it to train images annotations and the subfolder images. Okay. So this subfolder. Okay. So we have copied the images, then we have copied the validation images. And here, if we look at the annotations file in the notebook, this is how it looks like. Sorry. So the first section, images section, each element contains these 4 pieces of information. And the second half of the section is about annotations. Yeah, so this is the annotation section. Again, each element contain information about each object, right? So we map it to the image using this image ID, and then the 4 bounding box coordinates, and finally the category ID. Okay. All right. So we use the images from this folder, and then we use the annotations created using this make sense to prepare this file for the train as well as for the annotations. Now we can use these folders to train an object detection model using SageMaker's Jumpstart TensorFlow algorithms. That's all for today. Thank you very much.